Hello machine learning enthusiasts, welcome back to Nur AI. If you are new here, let me introduce myself. I am Neha Attara, last year computer engineering student, and we upload machine learning projects and a lot more about artificial intelligence here. Today we are going to talk about the most demanded library of machine learning, which is TensorFlow. So if you want to become a data scientist or a machine learning engineer, you must know TensorFlow. And one more thing I want to tell you guys, that if you are liking our video, watching it, then why don't you subscribe our channel? Please do subscribe our channel so that we can get motivated to make more videos like this. Thank you. So let's move on towards the video. TensorFlow. TensorFlow is an end-to-end open source platform for machine learning. It has comprehensive, flexible ecosystem of tools, libraries, and community resources that let researchers push the state of the art in machine learning and developers easily build and deploy the machine learning powered applications. It is licensed by Apache License 2.0. Its latest release is 2.2.0. The stable release of TensorFlow is 2.2.0 May 20 in May 2020. The initial release date of TensorFlow is 9th November 2015. Developers is Google Brain Team. And TensorFlow is written in Python, C++, and CUDA. Platforms where TensorFlow can be used are Linux, Mac OS, Microsoft Windows, Android, and JavaScript. Now, this was TensorFlow. Why it is so popular? Let's talk about it. The major credit goes to the soaring popularity and contributions across various forums such as GitHub, Stack Overflow, and Quora. The fact is, TensorFlow being used in over 6,000 open source repositories, showing their roots in many real world research and applications. Many popular companies such as Nvidia, Twitter, Snapchat, Uber, and more are using TensorFlow for all their major operations and research areas. On one hand, someone can make a case TensorFlow's popularity is based on its origins or legacy. TensorFlow, being developed under the house of Google, enjoys the reputation of the household name. There is no doubt TensorFlow has been better marketed than some of its competitors, but that's not the full story. There are many compelling reasons why small scale to large scale companies preferring using TensorFlow over other machine learning tools. Moving towards the TensorFlow key functionalities, TensorFlow provides an accessible and readable syntax, which is essential for making programming resources easier to use. TensorFlow provides excellent functionalities and services when compared to other popular deep learning frameworks. These high level operations are essential for carrying out complex parallel computations and for building advanced neural network models. TensorFlow is a low level library which provides more flexibility. Thus, you can define your own functionalities or services for your models. This is very important parameter for researchers because it allows them to change the model based on changing user requirements. And also, TensorFlow provides more network control by allowing developers and researchers to understand how operations are implemented across the network. They can always keep track of new changes done over the time. TensorFlow provides pre-built functions and advanced operations to ease the task of building different neural network models. It provides required infrastructure and hardware, which makes them one of the leading libraries used extensively by researchers and students in the deep learning domain. In addition to research tools, TensorFlow extends the services by bringing the model in production using TensorFlow serving. It is specifically it is specifically designed for production environments, which provides a flexible, high performance serving system for machine learning models. TensorFlow provides distributed training. The trend of distributed deep learning began in 2017 when Facebook released a paper showing a set of methods to reduce the training time of convolutional neural network model, the CNN model. And the test was done on ResNet 50 model on ImageNet dataset, which took 1 hour to train instead of 2 weeks. This revolutionary test has opened the gates for many research work which have massively reduced the experimentation by running many tasks in parallel on multiple GPUs. Google's distributed TensorFlow has allowed all the researchers and developers to scale out complex distributed training using inbuilt methods and operations that optimizes distributed deep learning among servers. Google's distributed TensorFlow engine, which is a part of regular TensorFlow, works exceptionally well with the existing TensorFlow's operations and functionalities. It has allowed exploring two of the most important distributed methods. First, distribute the training time of a neural network model over many servers to reduce the training time. Second, searching for good hyperparameters by running parallel experiments over the multiple servers. There is TensorFlow for web, mobile, edge, embedded, and more. TensorFlow.js for machine learning on the web. TensorFlow Lite for mobile and embedded ML. TensorFlow Hub for reusable machine learning. TensorBoard for visual debugging. Sonnet to build complex neural network models. All of these factors have made the TensorFlow library immensely appealing for building a wide spectrum of machine learning and deep learning projects. This tool has become a preferred choice for everyone from space research giant NASA and other confident government agencies to an impressive roster for private sector giants.